Hello everyone, my name is Raj Rishi Singh of batch A2B3 roll number 60. Our today's topic is about the Dutch algorithm. What is Dutch algorithm? Dutch algorithm is in the quantum computers, and let us start the Dutch algorithm. What are we going to learn in the Dutch algorithm? What are the steps? So, in today's video, we are going to learn about introduction to qubits, the black box, what is the black box, the difference between classical and quantum, which is better, classical or quantum computers, the circuit blueprint, and Hadamard gate, oracle, what is the role of oracle, the three-step mechanism, measurement and result, the real world significance of quantum computers, and in last we are going to study the summary. So let us start from the power of qubits. First of all, what is a qubit? In classical computer, they rely on bits 0 or 1, whereas in quantum computers they rely on qubit. So through superposition, a qubit exists in a complex linear combination of 0 and 1 gate. In classical computers, they use 0 or 1, whereas in quantum computers, they use qubits. Qubits are used in quantum computers. Next is the problem constant versus the balance. The black box oracle. The in Oracle there is a black box in which we cannot know what is hidden. The thing is hidden in the black box. The function is hidden. So there are two things, constant and balance. In constant, the output is always the same, whether you give 0. So if you give 0 as input, the output will be 0. And if you give 1 as input, the output will be 1. So the output is always same. F of 0 will be equals to f of 1. Whereas in balanced, the output flips. So if you give 0 as input, output will be 1, and as 1 as input, so output will be the 0. So it flips. It keeps a balance. In constant, there is always the same output, and in balance, the output is flipped. So the next is the circuit blueprint, which is shown in the diagram. The top qubit is shown, bottom qubit, Hadamard gate, the oracle. Next is the Hadamard gate. Hadamard gate is transforms a definite state into a superposition. Adamant gate actually it puts the computer into a state where it can process all the inputs simultaneously. That is Adamant gate, the superposition engine. It superpositions. The next slide is about the phase feedback of the oracle. So we cannot read the bits inside a black box. Inside of the black box is hidden and we cannot read it. So instead, we use the oracle. The oracle kicks the result back into the phase of the input qubit. So we use the phase feedback of the oracle to get the input of qubit. Next are the step by step. We start with the 0 on top and 1 on the bottom. Then we apply the Adamant gate on board which creates a working state. Next, this is the query and kickback. Next is the interference. When we apply a Hadamard gate, it causes in the constant function, it causes constructive interference for the zero gate. In constant function, there is constructive interference for the zero gate, whereas in balanced function, constructive interference is for the one gate. Okay. Next is the measurement in results. The weights cancel out the one state, the weights cancel out the zero state. This is for constant and this is for the balanced one. Hmm. The next is about the real world significance. The real world significance of this Dutch algorithm. So Dutch algorithm is generalized from Dutch Josa for n bits which shows a massive gap. So this is the proof that in real world Dutch algorithm is very useful and it is better in class. It is better. The quantum computers are better than the classical ones as it gives the step by step procedure. Step by step procedure. Next, so from here, this is the summary what we have learned in this whole video. We have learned about the constant or balance function, the the constant and balance, the why quantum computers are fundamental better than the classical ones, the superposition, phase feedback, plus the constructive interference. We also learned about Hadamard gate, etc. So this is the video. Thank you. Thank you, sir. Thank you very much.